This one, right? You guys see my screen?
Yes.
Yes.
All right. So 18 looks like 17. So let's do 17. And let me open the whiteboard.
The homework is number 17.
Okay, number 17. So let's do 18 then. Okay.
Okay.
18 looks similar. All right. So let me share my whiteboard. So solve for x. And the question is x squared minus okay. So the question is to solve by factoring. We're actually using the quadratic formula. Solve for x using okay, the quadratic formula. Okay, not by factoring, but this time using the quadratic formula. So you got to follow the instructions because we have different methods. We have many methods of solving quadratic equations, and the quadratic formula is one of them. So first, we need the quadratic formula, which is given like this. A and C. Actually, for AC. The whole thing over 2A. Not just the radical, but the whole thing should be over 2A.
Professor, I have a question.
Yes, go ahead.
Before we're using quadratic formula, this formula, and can we use like factor first?
Can we use factoring, you said?
Yes.
No, this is a different method. So factoring is a different method than the quadratic formula. So use the method that the question is asking you.
Oh, okay. All right.
Unless the question does not tell you which method to use, then you can use either one. Okay.
Oh, okay.
In this
right,
quadratic formula, which is this. So let's see how this works. So we have our equation. So basically these numbers come from here. So this is the standard form. This is the standard form of all quadratic equations. Okay, so these numbers here, A, B, and C, actually these numbers come from here. So whenever you have an equation, first you need to write it in standard form. It has to be in this form. As you can see, we have 0 on the one side, and all the terms should be on the other side. So we're going to do the same thing here. So we're going to take our equation, and we're going to try to write it in the standard form. So what do you do here? What do you do to this equation to make it look like this form?
So you move the 2x to the left, right?
Exactly. You got to move this over. It's like here we should have nothing here but 0, and all the terms should be on the other side. So it's going to be x to the second minus 4. Or before that, let me move the 2x over next to the x. 2x.
Okay. So we could like arrange them right away, yeah?
That's right. So the 2x moves over, change the sign. So this is a positive 2x. It turns into negative 2x.
Okay.
And the negative 4 stays here. We're not changing the sign. It stays on this side of the equal sign.
Okay.
Equals what?
0.
That's right. If you move this over, you have 0 left. Now, as you can see, this looks like the standard form. The equation is in standard form. After you change it to the standard form, now we're going to start getting A, B, and C. Don't get the A, B, and C yet here. It will be wrong. We have to do that after we move the terms to one side. So let's get those terms. So A, what is A? What is B? And what's C? So A.
So 1.
A, that's right. A is the invisible one. So A is next to the x to the second. The invisible one here, unless you have a different number. So A is 1.
Okay.
What's negative? B.
Negative 2.
That's right. B is next to the x. So it's negative 2. Finally, C is the number that's by itself.
Negative 4.
That's right. Will be negative 4. Okay, and once we get those numbers, please, if you have any background noise, please turn it down or mute your mic. Okay, so now that we have here, we're going to take A, B, and C. We're going to plug those into the quadratic formula.
Oh, okay.
Someone has background noise, and please mute your mic or turn the noise down. It's like a TV playing in the background or something. Benicia, is that you? I think you have some background noise.
Wait a second.
Thank you. All right, so this is basically A, B, and C. You just need to plug those into the quadratic into the quadratic formula. We're going to take all these. We're going to put them into the formula. So we're going to have.
Okay.
Thank you. So we're going to have negative. So when you plug these, be careful that you plug these correctly into the formula. So we have negative B. So first you're going to put a negative. It's always going to be there. And put some empty parentheses for B, whatever B might be. In this case, the B is negative 2. So I'm going to put negative 2 here. So we have two negatives, one from the formula, and the other one because B has a negative. Plus minus, so radical B squared, again, put some empty parentheses for B, which is 2 in this case, to the second, or negative 2 actually. So B is negative 2. Then plus 4, okay, 4 times A times C. So I'm just going to write empty parentheses for A and C. What goes into the first set of parentheses?
1.
The A, that's right. The A,
Oh, I'm sorry. Yeah.
right, 1.
Professor, this is a minus 4. It's not plus 4.
The
formula is
Minus.
For the formula, yes, you're right. You're right, 1. Yes, there should be a minus here. It's minus. That's right. Thank you. Let me fix this. So it's going to be minus 4 times A times C. C, which happens to be minus 4 as well. So holding over again, you want to write 2 and parentheses, empty parentheses for A. It's very important that you put those parentheses like that. And again, A is 1.
1.
So you get A, B, C, first step. Secondly, plug those here. Be careful when you plug them. Now we just need to simplify this and we're going to get our solution. So X will be, so that's positive 2 plus minus negative 2 squared. That's negative 2 times negative 2, which is
4.
That's right, positive 4. Now be careful with this part. So it's not a distribution. It's 2 multiplications. You're going to multiply these two. Okay, so negative 4 times 1, which is negative 4, times negative 4, that will be
Plus.
Plus, I'm talking to everyone in the class, not just Venetia. Please feel free to participate, everybody here. This
Plus 16.
16.
plus 16. Okay, again, we did this first. -4 times 1, which is -4. And the result times -4, which is positive 16. It's not a distribution. It's not -4 times this, -4 times this, but we have two multiplication. We do the first one, and then the result is multiplied by the second one. The whole thing over 2. All right, almost there. So now 4 plus minus 20, right, over 2a. If you're lucky, you may end up with a number that has a perfect radical, for example, 25 or 16. In that case, you will have two integers as the solution. Or if you don't get a perfect radical, you can try to simplify this. So obviously, this doesn't have a perfect radical. So we're going to try to turn this into two numbers. Well, two numbers are multiplied to 20, one of which is a perfect radical. What are the two numbers?
2
4 and 5.
5 and 4.
4 and?
5.
That's right. So we're going to use 4 times 5. Why? Because radical 4 will be 2.
2.
And 5 can't simplify. So instead of using, for example, 2 and 10 both don't have a radical, don't have a perfect radical square root. Instead, 4 and 5 are better. So 2. So now we can say x is 4 plus minus, and this 4 moves outside, so the square root of 4 is basically 2. And the 5 stays in. Square root of 5 is a decimal, so we can leave it inside the radical. So that's basically what actually we can do something else. We can do, now we can split this, or before that, we can simplify this a little more. Can someone tell us what we can do here to simplify this solution?
Factor it out.
Say it again, Tank?
Factor it.
That's right. We're going to factor here. We want to cancel these two, but we want to factor out 2 from here, move it to the front, and then cross them out. So the common factor between these two is 2. So we're going to put 2 parentheses. If you move 2 outside, or if you divide by 2, what's left here?
2.
Plus, minus. If you move these 2 out to the front, what's left?
Radical 5.
Just radical 5. That's right. And the whole thing over these 2. Now we can go ahead and cross out those 2's. Because it's the same thing, we can simplify that fraction. And finally, the solution will be x, just this, 2 plus minus radical 5. Okay, and that can't simplify. That's basically the final answer. Unless you end up with an integer here, for example, let's say 4 or 2 or 3, then you could turn this into two solutions, one with a plus. For example, if you got 3 here, it would be 2 plus 3, one solution, and the other solution would be 2 minus 3, for example, if you got 3 here. But in this case, we can leave it like this with 2 solutions plus minus radical 5. Okay, so that's basically how you solve equations using factoring. If you look at this here, you can also check your solution using factoring, because factoring is usually easier. Try to factor this. Try to think of the solutions using factoring after you solve this. Well, actually, the reason why we use the quadratic formula is because sometimes we can't factor. For example, here, can you think of two numbers that multiply to -4 and add up to -2?
No.
Let's think again. So -4, -2. So there's no way we can find two numbers that multiply to -4 and -2, right? That's the reason why we have another method when factoring doesn't work. we can use the
Oh, I see.
okay? Not every solution, not every equation can be factored, but we can still find a solution. It looks a little complex here with the radical and everything, because when we factor, usually we find two integers, so we don't have any radicals in it. Okay, so keep that in mind. First, stand that for, make sure all your terms are on one side. When you move something to the other side, make sure you change the sign. Get A, B, and C, get the right signs, and be careful when you plug them into the formula. You have a lot of signs here, you can easily make a mistake. Simplify that.
Okay.
By the way, if you end up with a negative here, what if you end up with a negative here under the radical? For some reason, let's say we got negative 20 under the radical. Can you have a...
No, it doesn't exist. We can't have a negative under the radical.
That's
We
right.
should have x's that are above the zero. Zero or above the zero.
Okay, so if you have a square root, you can't have a negative here. So if you end up with a negative, make sure you didn't make a mistake. Then you can stop here, you say no solution, because this is undefined. Okay, so if you end up with a negative radical, assuming you didn't make a mistake.
Excuse me, Professor.
Okay, give me 1 second, let me just finish this. So if you end up with a negative under the radical, assuming you didn't make a mistake, so you say this is undefined, and you stop here, you say no solution. Okay, no solution. And you don't have to do this because you can't have a radical here when you have a square root. Unless the index is odd, for example, 3 or 4 or 5, then it's possible to have a negative. Okay, so in this case, I have a positive, so that's fine. Shabo, go ahead.
Thanks, Professor.
All right, no problem.
When we start solving equation with the radical,
Shaba, your audio is cutting off. Shaba?
I said we should find the domain first in the beginning before we start solving the equation.
It is possible to, yes, it is possible to evaluate this first in the beginning. Okay, before you start, if you want to evaluate just this, b squared minus 4ac, you can evaluate just that and see whether it's negative, positive, or 0. If it's negative, there's no solution. If this is positive, you're gonna have two solutions like we did here. And if it's 0, you end up with exactly one solution, which is basically negative b over 2a.
Okay, thank you.
Okay.
You can do that as well in the beginning. We call the determinant. All right, everybody. Everybody got this example? Everybody in the room, let's hear from you. Justice, Brian, Tamara, Sajita, Mehdi, Mahmoud, Hillary, Fariza, Dang, Muhammad, Kayla, Francis.
Yes.
Everybody got this?
Yes.
Yes.
Professor, I have a question.
Sure.
I saw it somewhere, or maybe you say only when it's the square root of 3, then will be I, right?
I'm sorry, repeat that again, Tang.
I saw somewhere it says, I think maybe square root of 3 will become a I, because negative, I's are negative, right?
Square root of 3. Now, square root of negative 1 is I. It's a complex number. Okay, but in our class we're only working with real numbers, so this is basically undefined in R. So radical negative 1, we say is undefined, or it does not belong. It's not in the group of real numbers, but it is in the group of complex numbers. Complex numbers are it's another set of numbers, another group which has all the real numbers in addition to this formula that that does not exist in the group of real numbers. I, okay, so I is a complex number. Okay, but don't worry about I for our class. We're only working with real numbers. So basically, we can't have a negative when we have an even. When we have an even index. Even could be 2, 4, 6, 8, and so on. But it is possible to have something like this when we have an odd index, for example, 3. This is basically the cube of -8. What is the cube of -8?
2.
-2.
Not 2, but what number multiplies by
Negative.
Negative.
negative?
-2.
Okay, it is possible to have a negative if the index is odd. So basically, a number that multiplies by itself 3 times to get -8, that number is -2. But if you have an even index, for example, this, what do you say about this one? This is even, could be 2, 4, 6. So what do you say about this expression?
No solution.
Positive. It's a positive answer. The answer got to be positive.
No, but this is an even index. We have a negative number here. This, again, is undefined. Just like here, we have an index. The square root, what is the index of the square root? What is the index here?
2.
2. Okay, so if this is even, then it's not a real number.
Oh, I see. So 4 is a no solutions.
It's undefined or not a real number. Okay, it's undefined or not in the group of real numbers. Or you simply say undefined. Okay, it's okay for this one, but not here. All right, so for us, we're only working with real numbers in this algebra class, college algebra class. So if you end up with a negative here in the quadratic formula by default, or there's an invisible 2 here. So if you end up with a negative, you say no solution because it's undefined. All right, does that make sense?
Yes, Professor.
All right, very good. Let's take other questions.